Hi, I'm Tate, and welcome to Cooking with Chemistry. So we're making pancakes with whipped cream and Arnold Palmer. So we got all the ingredients here, and to start off, we're making the whipped cream solution here. I'm gonna put this in the fridge. So we have our pre-made amount of whipping cream and sugar. So we'll just mix this. So we'll pause here, and so this would be this is a solution of, like I said, the whipping cream and sugar, and the whipping cream would be the solvent and the sugar would be the solute, since there's more whipping cream than there's sugar, and the sugar is dissolving inside of this, or inside of the whipping cream. So that's mixed pretty good. So next we'll place this in the fridge. And this would be an example of an exothermic reaction, because the energy inside of the whipping cream is being exerted into the colder air inside of the fridge. And next we'll move over to the pancake solution. So this is our dry solution of flour and a mix of other things. And the flour here would be the solvent, because it's the most abundant resource of this mix. And then we'll make the dry mix here, which is, we'll mix this milk, which is a solvent again, because everything else will be dissolving inside of this, with, this is the butter. We'll place this in the microwave for 15 seconds. And this would be an example of an endothermic reaction, because the heat surrounding the microwave is being absorbed by the milk and the butter. So now we've melted the butter a little bit, and we'll add half a tablespoon of this vanilla extract to get some flavor. So we'll just mix this in here, and then we'll add in this dry solution of the dry solution. So we'll just add this in here. Mix this up. And there was more, the wet solution was more abundant, so the wet solution would be the solute in this example, since there's more of it, and the dry solution was dissolving inside of it. And stirring the solution makes it more soluble. I think that's good. So we'll come over here and add our spray, which you can put over here. So this is a non-polar solution, and this is polar. And non-polar and polar substances don't attract, which is the reason why when I put this on, the pancakes mix won't stick to the pans. So we'll add this on the pans. We'll turn this on. Okay, so I put the pancake mix on here. For the pan, that would be an endothermic reaction, because it is absorbing the heat from the burner. And then it will be an endothermic reaction for the pancakes, because it will absorb the heat from the pan. So yeah, and we'll wait for these to heat up a little bit. And we'll add my pancake mix. So while that's cooking, we'll come over here to make our Arnold Palmer, which is a mix of lemonade and iced tea. And for mine, I'm going to do a 2-to-1 mix of lemonade to iced tea. And lemonade has an acidity of 2.6, and iced tea has an acidity of 3. So this is a very acidic solution. So I'm just going to eyeball this here. And in this solution, once again, the solvent would be the lemonade, because there's more lemonade than iced tea. Go back here. And then I'm gonna stir this as well, because stirring solutions make them more soluble. So I'm gonna add a little bit of water to this, because this would be very acidic and very bitter. So I'm just gonna add a little bit of water to make it a little more neutral and less acidic, less bitter, to make it taste better. Once again, stirring it to make it more soluble, which means it's more balanced, so you're not having more iced tea than lemonade all in one taste. And this is our final product, our pancakes with whipped cream and Arnold Palmer.